So today I'm going to be presenting ASIMPLELANG. This is our team's group project. It's a complete compiler and runtime environment that we built from scratch. My name is Shannon and I'll be presenting the project today on behalf of my team members, Swarag, Pin, and Ritish. Over the course of the project, we all focused on different aspects of the compiler design, implementation, and testing. Moving on to the project goal and architecture, our main goal was to design a language that feels like C, but is simple enough for us to completely control the compiler logic. To do this, we used ANTLR to generate the grammar, and then we wrote our own custom Java visitor, the interpreter Java, to handle the execution. Talking about the grammar design and precedence, our grammar is quite strictly defined. So we have the lexer that identifies all of the tokens and the symbols, and the parser that checks the sequence of those tokens to enforce correct syntax. A critical task was defining operator precedence, so we made sure that higher priority operations like multiplication and division execute before addition, and addition again executes before any of our logical operators. So this ensures that the abstract syntax tree is always correctly built. Moving on to runtime data handling. So when we talk about data in our language, everything is handled by one key class called the value class. So this is central to ensuring type safety in the interpreter. Every piece of data is stored in the value object, and this value object contains both the explicit type, which could be either integer type, float type, and also the raw value. Our interpreter checks that explicit type before performing any operation, so this prevents any illegal runtime errors. So for example, you can't perform a multiplication operator on a string, so you would always get the type of the data before performing any kind of operation on it. Runtime conversion and coercion. So we also implemented runtime type conversion or coercion within the value class. So this lets us support mixed type operations like maybe adding an integer value and a float value. For example, if you add an integer value 5 to a float value of pi, it detects that one of the values is pi, and it converts the int into a float value, and whatever calculation that we get, or whatever value that we get after calculation, the return type is also a float type. Moving on to scope and function management. To manage variables, we created the environment class. So this class handles our hierarchical symbol table and defines variable scope. The key is that every environment links to a parent environment, creating a scope chain kind of structure. So when our interpreter looks for a variable, it checks within the current scope, and if it finds a variable, then great. But if it doesn't, then it follows the chain up in the upward direction and goes all the way up to the global level. So every time we encounter a new local block, we create a new environment for that local block. So this guarantees correct block scoping. Function definition and calling. For functions, we scan the entire program and collect every function definition into a global symbol table. The function symbol stores all of the metadata needed, including the parse tree context for that function body. When a function is called, our code first pauses and then creates a fresh local environment for that particular function. And then it binds the arguments to the parameters and then executes the stored function body. So this handles parameter passing and scope isolation perfectly. Finally, we're going to move to the features that we implemented in our language. They're very simple features. This is what we could do with the time that we had, but we would love to extend on top of this in the future, maybe as a hobby project. So we've implemented primitive data types, like full support for the 5 primitive data types: int, float, bool, char, and string. We also have standard arithmetic. We have our 4 basic arithmetic operators. We have relational operators. We have assignment operators, the standard assignment operator and compound assignment operators, logical operations and or not, and we also have one-dimensional arrays. Control flow in functions. Here we have full support for and while loops, if-else statements, and ternary operators, and simple print statements. So that's the end of our presentation. I have added a PDF copy of this presentation under the document folder in our Git repository. So before we run the test program, I would just wanna review the test program real quick. Okay, my bad. Okay, so this is our test program. So I've divided this into 6 different sections. So section 1 covers arithmetic and types, and section 2 covers assignment operators and compound assignments, and section 3 and 4 they cover conditional and relational operations and logic, and section 5 and 6 they cover loops, arrays, and functions. So there are 15 different test cases, and here we also have printing, input, output, like outputting a string. So starting here, we have tried different arithmetic operators. If you see here, we've also taken care of coercion, and we've tested for it. X is a float type and A is an int type, so the expected output is a float value. And then here we've taken care of compound operations. Plus is equal to. We have conditional statements, true and false statements. We have if, else. Here we have taken care of ternary here. We have relational here, greater than, less than, equal to, not equal to. We have a for loop here that prints a sum from 0 to 2. And for the while loop, we have taken an example of factorial and taken that as a test case. It would print the factorial of 4. And then here we have arrays and string and character variables and function call. So here we have a function call where we are calling a function add2, which is here, which is going to add these 2 variables, x and y. So if you take a look at the README, you have the exact instructions to run the project. So you will be running this from the source directory. I'm going to start by downloading the ANTLR jar, and then generate the lexer and the parser, and then compile all of our files. And after compiling all our files, I'm going to run my test ASL file, which is my test for a simple language. So, okay, I wanted to expand it. So if you take a look here, we ran our test and we have our addition and our float arithmetic, and we have our compound assignment, conditional logic, relational logic, looping, and advanced calls, and all of them run as expected. So at the side of every test case, I have also added what is the expected value. I did notice one thing. So the test ASL that we're running from here, and this is the test ASL that we were expected to put in the data file. I'm just running everything from the source folder. So this is one more test case that we should be running that isn't here in my test ASL. So I'm going to place this here. This is taking care of coercion. So I'm going to save this file. Why can't I save it? Okay. So I'm going to run the test again just to look at that one particular test case. So we're adding a float and an int, and we get a float value. So we have all of them, arithmetic, compound. Here we have c is equal to 20, and then when we do a compound addition, we get 25, division, we get 5. This is our conditional logic statements. Our if else is a less than b, a is less than b, true, ternary is also if a is greater than b, which it's not, so it prints 200. And then this is greater than, less than, equal to. This is all pretty self-explanatory. This is printing the sum of when the higher end of the value I should be less than 3, so it prints the value of 1, 2, 3, the sum of 1, 2, 3. This prints the factorial, and this is like it prints the array. It prints the value at 2, which is 30. And then here it prints a string, and then here it calls a function, it adds 2 numbers. So that is the end of the presentation. I have updated the contribution text here in the document folder. We've also added the presentation PDF and updated the README file. So yeah.